Welcome to today's deep dive. Whenever we talk about the cloud in tech, we sort of treat it like magic.
Oh, absolutely. We just throw the term on marketing brochures or drop it into planning meetings,
Right, and there's this unspoken assumption that just by migrating to the cloud, poof, all of your infrastructure problems will just vanish.
which, as we know, is definitely not what happens.
No, not at all. I mean, if you've actually worked with these systems, you know the cloud isn't magic. In fact, if you approach it with the wrong mindset, it is a massive financial landmine.
Yeah, it really is.
And you listening, you probably already know the cloud isn't just, a giant hard drive sitting in someone's basement. But the trap we're exploring today isn't about what you inherently know. It's about how your brain is actually wired to act.
Exactly. Even seasoned engineers still instinctively treat the cloud like physical metal, and, well, it costs them dearly.
Okay, let's unpack this. We are pulling our framework today from a really brilliant narrative blog post by Aaron Rose.
Yes, it's titled The Secret Life of AWS, What the Cloud Actually Is, and it's from tech-reader.blog.
And what I love about this source is that it completely avoids reading like a dry technical manual.
Right. It's not just a list of specs. The author grounds the concepts in this incredibly atmospheric scene. We're essentially like a fly on the wall in this grand, quiet Victorian library over in London.
Such a great setting.
It really is. And we're listening in on this conversation between two colleagues. There's Margaret, who is a deeply experienced senior software engineer. She's seen, multiple eras of computing.
Yeah, she's been around the block.
Exactly. And then there's Timothy, her junior colleague, who is really just trying to build an accurate mental model of modern infrastructure.
And through their dialogue, the source reveals that mastering the cloud is, well, it's barely a technical challenge at all.
Yeah, it's actually a massive exercise in psychology and corporate economics.
Right, and breaking deeply ingrained human habits. So our goal today for you, the listener, is to take the most common definition of the cloud, the one Timothy starts with, and really deconstruct it.
Because if you carry old assumptions into these dynamic environments, you aren't just writing inefficient code.
No, you're going to make massive, incredibly costly architectural mistakes that just compound over time.
Definitely. So let's look at Timothy's starting point. He sits down across from Margaret in this library, and he pitches her his fundamental definition.
Which is pretty standard, right?
Very standard. He says, essentially, that the cloud is just someone else's computer.
Ah, yes, the classic line.
Right. He views it as this massive, highly reliable fleet of servers that a company rents instead of buys.
So you don't have to manage the physical hardware or, hire security guards for the building.
Exactly. You avoid all the real estate costs and just pay for the slice of computing power you use.
Now, on the surface, that sounds completely reasonable, and Margaret actually validates it as a fair starting point.
She does. Because the sheer scale of what major cloud providers have built is genuinely valuable.
Right. We're talking about colossal data centers, relentless hardware refresh cycles, and just massive power redundancy.
They've invested capital at a scale that almost no independent company could match. That infrastructure is very real.
But she immediately follows that validation up with a heavy warning.
Yeah, she tells him that if he stalks at that definition, if he truly just treats the cloud like a rented server, he'll capture almost none of its actual value.
Okay, wait. If it works to just treat the cloud like a rented server that you leave running, why does Margaret say it captures almost none of the value?
Well, the reason it's a trap is that it leads directly into an instinct Margaret calls lift and shift.
Lift and shift.
Right. If your mental model tells you the cloud is just someone else's computer, your natural human behavioral response is to use it exactly the way you used your own computer.
Oh, I see. So you provision a virtual server, spend hours manually configuring it.
You leave it running 24/7.
Right, and you only log into it when a process crashes.
Exactly. You take all of your old, rigid on-premises habits and you just drop them into this brand new environment completely unchanged.
The source delivers this fantastic analogy to explain why this is so detrimental.
Oh, the bus analogy.
Yes. Margaret tells Timothy to imagine that he has grown up his entire life taking the bus everywhere. He knows the routes perfectly. He has the schedules memorized.
He knows exactly where the stops are.
Right. And he knows exactly how much change to bring. That entire system forms his mental model for transportation.
And then one day, someone hands him the keys to a sports car.
Exactly.
What's fascinating here is how perfectly this captures the cognitive dissonance of moving to the cloud. You've been handed a brand new, incredibly capable dynamic tool, But because your brain is entirely wired for the bus, how do you drive that car?
You drive the car strictly along the bus routes.
Yeah.
You literally pull over at every single bus stop. You wait for the scheduled timetable before you accelerate to the next block.
Yeah.
Now, will you eventually reach your destination? Yes, absolutely. But you are using the tool entirely wrong.
You're missing the entire point of having a car.
Because you're artificially applying the constraints of the old system onto the new one.
Exactly. The cloud is the car. But most engineers, when they first get their credentials for AWS or Azure or Google Cloud, they drive it like a bus.
They bring their scheduled, static ways of working into an environment that was fundamentally built for elasticity and movement.
Yeah. But, if lift and shift is so clearly inefficient, why do smart, highly paid engineers instinctively do it?
Right, that's the big question. And the text shifts beautifully here from technology into psychology. It really comes down to our profound human craving for physical control.
Yeah, Timothy actually admits this emotional block to Margaret. He tells her he hates not knowing where his data physically resides.
Which is totally relatable. When he had a server sitting in a rack down the hall in his own office building, it felt solid.
He could walk up to it. He could actually hear the fan spinning.
There was an immense comfort in that physical proximity. Now someone is telling him his database is just floating around in some abstracted data center across the country, and it causes this real anxiety.
Because we inherently trust what we can see and touch. But Margaret drops a necessary reality check on him here.
She asks him to rigorously examine that feeling of safety, right?
Exactly. She says, if that physical server in his office building fails, like if the power supply blows or the hard drive crashes, what is his actual backup plan?
What's the mechanical failover process? How many hours or even days will the business be offline while they wait for a replacement part to be shipped and installed?
The hard truth is that for most organizations running on-premises hardware, redundancy is deeply insufficient.
The data felt safe purely because it was close. But physical presence does not equal actual architectural safety.
No, it doesn't.
So what is the alternative then? How does the cloud actually handle safety if we can't physically touch the machines?
Well, the source explains the sheer architectural scale of the cloud. Your data doesn't just sit on one machine. It lives in a region, which is a geographic area like Virginia or Ireland.
Okay.
But within that region, there are availability zones. And these availability zones are entirely physically separate data centers.
Oh, wow. So they sit on different floodplains, they're connected to different power grids, and they use different internet service providers.
Exactly. And this is where we have to look at the actual mechanics of how this keeps a system online.
Right.
If a backhoe accidentally cuts a major fiber line at one of those data centers, or a localized storm knocks out the power grid, the cloud's load balancers instantly detect the dropped connection.
So within milliseconds, before a user's web page even finishes loading, the traffic is automatically rerouted to a replicated instance of your application running in a completely different availability zone.
Yes. But Margaret mentions a critical caveat here, and it's doing an enormous amount of work in her argument. Well, she points out that the cloud is incredibly safe, but only if you configure it correctly.
Ah.
The cloud gives you the raw materials, the geographically isolated zones, the load balancers, the replication tools for unprecedented safety.
Yeah.
But it does not build the architecture for you.
So you have to consciously choose to build your application to span across those zones. You have to actively trade that comforting illusion of physical proximity for the reality of architectural redundancy.
Exactly. And once you accept the physical hardware isn't actually safer, you start buying physical hardware.
Which means the conversation leaves the engineering department entirely and fundamentally alters how the accounting department works.
Yes. Margaret calls this the most hidden shift of the cloud. It's an economic paradigm shift from CapEx to OpEx. Capital expenses versus operational expenses.
Let's break that down. In the traditional on-premises model, infrastructure is a capital expense, right?
Right. You buy the physical hardware, you spend hundreds of thousands of dollars up front, you depreciate the cost of those servers over 3 to 5 years, and it becomes a fixed sunk cost.
Now, because you cannot magically summon a new physical server out of thin air when web traffic spikes, how do you decide what hardware to purchase?
Well, you have to size your purchase for your absolute worst-case scenario. You size the entire data center for your peak Christmas load.
Which means you're buying enough computing power to handle the busiest day of the entire year.
Yeah.
But what does that mean for an average Tuesday in March? It means those expensive servers are sitting there maybe 70 to 80% completely idle.
Exactly. But here is the crucial psychological factor.
Hmm.
Because the company has already paid for the machine, leaving it running at full capacity costs nearly zero extra dollars.
The money is gone. The budget is spent.
Right. Then you move to the cloud, which operates as an operational expense,
Or,
or OpEx. You only pay for what you consume.
okay.
That massive cluster of servers you need for the December holiday rush, it does not even need to exist in March. You provision the servers when the demand hits, and you completely destroy them when the demand drops.
Wait, I'm stuck here. I'm trying to put myself in Timothy's shoes, and if I'm only paying for exactly what I use, that sounds objectively cheaper than buying a massive server that sits idle for 11 months of the year. How could this possibly be a trap?
It is better business logic? Absolutely. But it's a trap because of those deeply ingrained habits we just discussed.
The lift and shift.
Exactly. In the old CapEx model, leaving an idle server running was practically free. But in the OpEx cloud model, the billing meter is always spinning.
Oh, wow.
Leaving a server running costs you money every single hour of every single day.
Right.
Whether that server is actively processing customer transactions or just sitting there doing absolutely nothing, you are being billed.
So the cloud severely punishes a lack of intentionality.
It really does.
The text gives this fantastic wince-inducing scenario that is, honestly, practically a rite of passage in the tech industry.
Oh, the forgotten test instance.
Yes. A developer decides they need to test a new feature. They spin up an EC2 instance, which is essentially a virtual server providing raw compute power. They run their quick tests, they get an email, they get distracted, they go home for the weekend, and they completely forget to shut the instance down.
And because the cloud doesn't care if you're actively using the resource, it only cares that you requested it, that server just sits there, quietly running.
Just quietly billing the company's credit card by the hour at 3 in the morning on a Saturday for 6 straight weeks.
Yeah, in the old days, you didn't have to think about a server once it was bolted into the physical rack. But in the cloud, you have to constantly ask yourself, what am I running? Why am I running it? And exactly when is it scheduled to be turned off?
And because the cloud operates on this on-demand financial model, it completely removes physical constraints. If your company has the budget, your capacity to spin up resources is functionally infinite.
Which is wild to think about.
It is, but Margaret makes a brilliant point here. Removing physical limits creates a brand new psychological danger. She describes the feeling of operating in the cloud to Timothy as intoxicating.
Intoxicating.
Yeah. I mean, imagine spending your entire career in a world where ordering a single new server required a purchase order, 3 levels of managerial approval, and a 6-week delay for shipping and installation.
And then suddenly you're in a world where you can provision 1,000 servers with a single line of code in 3 seconds.
You can store petabytes of data without ever worrying about a hard drive filling up.
It feels like having a superpower. But the downside to that intoxication is that it leads to what Margaret terms scaling without thinking.
Ah.
This is where the discipline of software engineering can completely erode. In the old CapEx days, physical and financial constraints actually served a vital purpose. They forced you to be disciplined.
Let's look at how that actually plays out mechanically. Imagine you have a database query that's running incredibly slowly and timing out.
Okay.
In the old days, you couldn't just throw more hardware at the problem because you simply didn't have any more hardware. You had to sit down, open up the execution plan, figure out why it was doing a massive table scan, and rewrite the SQL query to be more efficient.
You had to actually optimize the code.
Right. But in the cloud, if the query is slow, why bother spending 3 days optimizing the code when you can just click a drop-down menu, double the RAM on the database server, and force the query to finish in time?
Exactly. And if we connect this to the bigger picture, this is the most critical realization in the entire text. The cloud does not fix bad architecture.
Oh, wow.
It amplifies it because there's absolutely no friction to scaling. A poorly optimized system at a small scale will effortlessly compound into a massively expensive disaster at a large scale.
It's like pouring high-octane fuel into an engine with a cracked block. You'll go faster for a minute, but the catastrophic failure is going to be spectacular.
Precisely. The constraint of physical hardware was actually acting as a safety guardrail. When you remove that guardrail, the cloud is very forgiving of your short-term mistakes.
Because you can just scale up your servers to survive a sudden traffic spike today.
Right. But it is utterly merciless toward your long-term mistakes because it will just keep automatically scaling and continuously billing you for your own underlying inefficiency.
So we've explored how treating the cloud like a physical server leads to the rigid lift and shift bus analogy.
Yeah.
We've seen how the psychological need for physical control blinds us to how architectural redundancy actually works. And we've seen how the OpEx financial model, combined with infinite capacity, removes our discipline and amplifies bad architecture.
So much to unpack.
Exactly. So now, how do we rebuild our understanding? What is the mental model Margaret ultimately offers to replace the idea of someone else's computer?
Well, Margaret tells Timothy to stop thinking of the cloud as a computer entirely and start conceptualizing it as a utility. She compares it directly to electricity or water.
Okay, let's break down how that metaphor actually functions day to day. When you plug a lamp into the wall in your house, you don't own the power station, you don't manage the massive step-down transformers in your neighborhood, and you don't maintain the miles of high-voltage wiring.
You simply connect to the grid and you draw exactly the amount of power you need precisely when you need it.
Right, you don't think about the massive generators turning miles away. Your only concern is the appliance you're actually trying to power.
It is a brilliant way to view the abstraction of the cloud. But, as Margaret explicitly warns Timothy, utilities have meters.
Oh, right.
And that meter spins whether you're using the power wisely to read a book in your living room or whether you are foolishly leaving every single light on in an empty office building all weekend long.
The electric company does not care if the light is providing value to you. They only care that the switch is flipped to on.
Which fundamentally shifts where your responsibility lies.
Yeah.
If you're working in these environments, your job is no longer managing the infrastructure.
You aren't racking servers or swapping out dead hard drives. Your job is to manage your intent.
Yes, intent.
You have to use that infinite grid deliberately. Every single resource you provision needs a clear reason to exist, and it needs an automated plan for when it should be turned off.
And Margaret gives a very stern warning about default settings here. She tells him that the cloud will happily accept every single decision you choose not to make, and it will simply make one for you.
Wait, really?
Yeah. If you don't consciously decide on your auto-scaling limits, the cloud will keep scaling indefinitely. If you don't set strict data retention policies, the cloud will keep your automated daily backups forever.
Which means charging you every month for petabytes of entirely useless, outdated data.
Exactly. While some default settings are excellent for getting started, leaving them untouched in a production environment is incredibly expensive.
Okay, let's unpack this. So what does this all mean? If we zoom out and look at the journey Timothy goes on in this library, it provides a roadmap for anyone trying to master modern infrastructure.
It really does.
For you, the learner, mastering the cloud means having that realization that you're sitting in a sports car and you need to start driving it along the old bus routes.
Right.
It means accepting that putting your hands on a physical server is an illusion of safety, and true reliability comes from building across multiple geographic zones.
And it means internalizing that the financial meter is always running. Having infinite capacity at your fingertips requires a level of strict optimization that physical constraints used to handle for you.
And as Timothy leaves the library, he realizes what his next step actually entails. He needs to learn the specific individual services the cloud offers.
Yeah, he needs to understand things like S3, which act as a limitless object storage system for holding raw files and backups.
He needs to look at SQS, which provides a queuing system for organizing background tasks so servers don't get overwhelmed.
And he needs to master EC2, the virtual servers that provide the actual compute power.
But he has to approach them not as generic, always on assumptions, but as highly specific tools designed to be turned on to solve a specific problem and then turn off.
I love that shift in perspective.
Before we wrap up, what is the biggest takeaway you are chewing on from Margaret and Timothy's conversation?
It leaves me with a highly provocative thought about the future of our industry, honestly.
Yeah.
We spend an immense amount of time and money training engineers on how to build things.
Right. We teach them architectures and scale systems globally.
But if the hardest, most financially punishing lesson of the cloud is simply remembering to release what you no longer need, what if the ultimate skill for the next generation of software engineers isn't actually knowing how to turn things on?
Oh, wow.
What if the true mark of a senior engineer is developing the psychological discipline to turn things off in a world that constantly encourages us to hoard limitless digital resources?
The discipline to turn things off, that reframes the entire job description.
It really does.
Thank you so much for joining us on this deep dive. Whether you're prepping for a system architecture meeting, trying to wrangle your company's AWS bill, or just satisfying your own curiosity about how the modern internet actually runs, we hope this conversation gives you a much sharper lens to view the cloud.
Absolutely.
Take a deliberate look at your own projects today and see if there are any metaphorical lights you might have left on. And remember, the next time someone tries to tell you the cloud is just someone else's computer, ask them if they are driving a car on a bus route. We'll see you next time.